here's example 2 from the finding mass percent from chemical formula topic. And this time we have a different substance. This is the chemical formula for acetone. And it says calculate the mass percent of carbon in acetone. Round your answer to the nearest percentage. So let's go back. How do we find mass percent, also called percent composition or percent by mass? Well, here it is. Mass percent is going to be equal to N, which is the number of atoms of the element that you're interested in. We're interested in carbon, so the number of carbon atoms times the atomic mass of carbon divided by the molecular mass of the compound. I'm using molecular mass of the compound because this is a molecular compound, not an ionic compound. If this were an ionic compound, we'd be looking at formula mass. Both found the same way. So in order to do this, I'm again going to use the molecular interpretation of this chemical formula. It says 1 molecule of acetone has so many atoms of carbon, so many atoms of hydrogen, so many atoms of oxygen. Now here again, we're interested in carbon. So let's find N. What is the number of carbon atoms in 1 molecule of acetone? Well, let's take this total number here, found by looking at the subscripts. So this 2 applies to everything within parentheses. So I have 2 carbon atoms. And then I need to ensure that carbon isn't present anywhere else in this molecule. If I scan through, I see it there. So we have 2 carbon atoms here. But how many do we have over on this side of the molecule? Well, there's no subscript here, but we assume that it's 1. There are no parentheses to multiply that 1 by, so 1 carbon atom here. Okay, so a total of 2 plus 1, that's 3. So 3 times 1 is still 3. So we have 3 carbon atoms in 1 molecule of acetone. So we have N. In this molecule, there are a total number of 3 carbon atoms. What is the atomic mass of the element? Well, the atomic mass of carbon is 12.011 AMUs. All right. So we have this. We have this. The last thing we need is either the molecular or formula mass of the compound. This is a molecular compound, so we will go with this one. We need to find the molecular mass of this compound. How? By adding up all of the individual masses of all of the atoms present. Which kind of atoms are present? Well, there are carbon atoms present. What else? There are hydrogen atoms present. What other element do we see in this compound? There's oxygen also present. So we have carbon atoms, hydrogen atoms, and oxygen atoms. The next question we need to ask is how many? We've already found that we have 3 carbon atoms present. How many hydrogen atoms do we have? So there are 3 here, but there's also a 2 outside this parentheses. So 2 times 3, 6. How many oxygen atoms? Oxygen is only found here, and there's only 1 oxygen atom. So in this molecule, 1 molecule of acetone has a total of 10 atoms, 3 carbons, 6 hydrogens, and 1 oxygen. So if I take these number of atoms and multiply the number of atoms by the individual atomic masses of each atom, we can find the total mass of this molecule. So the atomic mass of carbon is 12.011. The atomic mass of hydrogen is 1.0079. And the atomic mass of oxygen is 16.00. So what is 12.011 times 3? 36.033 AMUs. What is 1.0079 times 6? 6.0474. What is 16 times 1? 16. Now, I'm not really worrying about significant digits right now. Let's just go ahead and get it added up and get a calculated value. So I'm going to add all of these atomic mass values together. So I'm looking at it right now. All of the carbons in this molecule contribute a mass of 36 AMUs. All of the hydrogens in this molecule contribute a mass of 6 AMUs. All of the oxygens in this molecule contribute a mass of 16 AMUs. So 16 plus 6.0474 plus 36.033 gives me a total of 58.0804 AMUs. So that is the molecular mass, and I'm going to abbreviate molecular with MOL, even though that may not be the appropriate abbreviation. It's 58.0804 AMUs. All right, so now we have everything that we need. We have this, this, and this. So now I can find the percent by mass of carbon in acetone. Let's plug it into the formula. The percent by mass of carbon is going to be equal to the number of carbon atoms, which is 3, times the atomic mass of carbon, 12.011, the units of atomic mass are AMUs, divided by the molecular mass of this compound, acetone. We found that to be 58.0804 AMUs. So 3 times 12.011 is 36.033 divided by the molecular mass, 58.0804, and all of this needs to be multiplied by 100% to convert it from a decimal to a percentage. So finally, if I take 36.033 and divide it by 58.0804, what I end up with is 0.620399. The units of AMUs cancels. Again, this needs to be multiplied by 100 to convert it to a percentage. I end up moving my decimal place to the right 2 times and round it to the nearest percentage. This would round to 62%. What does this answer mean? What this answer means is it doesn't matter how much acetone I have. The total mass of that acetone, however much it is, 62% of that total mass can be attributed to the carbon present in that substance. So the percent by mass of carbon in acetone is 62%. 62% of all of the mass of pure acetone is from the carbon atoms that are present.